My name is Kim, representing Complex Systemic, and we're here to present an information fusion framework for situation assessment. With our diverse technical team, we're developing decision support solutions for government and private contracts. Based on our experience, we develop tools to analyze trends and extract information from data for detection, tracking, and identification. Our system is based on the observe, orient, decide, act OODA loop for human decision making. Starting with combining observations, orienting to obtain insight and prediction from the data, finally deciding and acting based on the information and events detected. At a higher level, our system would start by fusing information from multiple sensors, context analysis to weight the sources and rank the data, and predictive models to identify the deviations integrated into the decision engine. When developing decision support, one challenge is to make sense of multimodal data. If you look at this example post, they say, an image speaks 1,000 words. But what if this image is not real? Then we need to check for manipulation, check if the location stated in the text is correct, and if the time of this post matches with the situation in this image. We have to consider all these features at the same time. That's not all. Just from these two sources, we have to associate and understand that these are talking about the same topics, even with different keywords. Then we can determine which perspectives may be true, or need scientific claims. At a network level, different patterns of behavior may exist due to what's known as echo chambers. These are clusters of like-minded people, for example, social groups sharing a common interest, forums, or friend groups. Similar perspectives of news are propagated by the bandwagon effect in these clusters. We believe predicting these propagation effects and identifying differences using fake or real news can help in understanding data and its impact. With our innovation, we use information fusion to decompose a scenario to manageable subproblems. The first low-level AI will answer the question, is the source trustworthy? We will combine multiple modalities to analyze the trustworthiness and detect signs that reduce trust, image manipulation being one of them. This gives us some idea to rank each source of data. After that, multiple sources will be combined to associate different or conflicting opinions. Another innovation that we have is to use prediction to find indicators of propagation of fake news. By finding out the impacts of information transmission based on the potential content and opinions, we can make better, informed decisions. For single source verification, we use a large training corpus to train AI models based on prior release of features. Research has shown that features like word count may correlate to the probability of fake news. We also identify relevant keywords to associate different topics. We would combine this with multimodal analysis in the mid-level approach. For example, image analysis algorithms look for signs of manipulation. By comparing features and signatures for stored databases, we can also see if the image is being reused from a previous event. So here, the user authority can give a weighting to the importance of a source to determine whether it's true, possibly a bot, or it could be a malicious user. The output here, for example, is whether there's a conflict between different modalities or the trustworthiness ranking itself. For multi-source verification, we would take all the outputs from the single source and multiple AI models. We would need to associate opposing or similar content together, and then we can determine if there's a conflict or not. Then, we'll verify with other sources, such as scientific sources or fact-checking websites. This allows us to flag the news content. Finally, with predictive modeling, we treat the propagation of information as a complex network. First, we discover clusters of nodes or users, which can be filtered by their opinion or content. With our analysis, we track and identify patterns, such as how far or large is this network, the number of users affected, and nodes of interest. These patterns can be used as features to determine false information and analyze the ripple effect on users. Conventional network models may only identify clusters. With our approach, we integrate the truthfulness ratings, so we can identify low-truth clusters and potentially vulnerable populations. To wrap up, CSI's decision support solution is based on information fusion and artificial intelligence to make sense of massive data. We analyze at the multimodal and multi-source levels and combine with prediction to form our core decision support framework. We at Complex System Inc. would like to thank you for listening to this presentation.